The Iron Dome is often perceived as a universal shield. Its function relies on a specific mechanical process, launching a 90-kilogram interceptor to detonate a cloud of high-velocity shrapnel near an incoming threat. But an intercontinental ballistic missile does not behave like a short-range rocket. A heavily armored ICBM re-entry vehicle drops from the vacuum of space, punching downward at speeds exceeding Mach 24. Against that velocity and heavy armor, the Iron Dome's fragmentation cloud is mechanically ineffective. It acts like dust hitting a speeding freight train. To survive this threat, the physics of interception must scale. Explosive shrapnel cannot stop an apocalypse. The Iron Dome is a specialized defensive system built for a highly specific environment. Stationed on the ground, it operates strictly as a short-range point defense system. Dissecting the Tamir interceptor casing reveals that it is not designed to physically strike a target. It uses a proximity fuse to trigger an 11-kilogram warhead, blasting an expanding ring of metal outward. This explosive shockwave is designed to shred the thin skin of low-velocity rockets, provided the detonation happens within the Earth's atmosphere. An ICBM operates under different rules. Its longest flight segment coasts at altitudes reaching 400 kilometers, passing through an absolute vacuum. Because there is no air to carry an explosive blast wave, a proximity detonation in space achieves nothing. At this altitude, the Iron Dome hits a hard physical wall. The solution for space interception is the Exoatmospheric kill vehicle. This hardware is devoid of explosive payloads. This kinetic energy equation shows how it destroys a nuclear weapon through a head-on collision at 10 kilometers per second. The massive destructive yield is generated entirely by the vehicle's mass and extreme velocity. No chemical explosives are required. To steer toward this collision in a vacuum, where aerodynamic sends are useless, the vehicle utilizes a divert and attitude control system. It fires bursts of gas through a cruciform thruster arrangement. Exoatmospheric defense requires transferring energy through surgical precision. However, an ICBM does not travel alone. Once in space, it releases dozens of lightweight mylar balloon decoys alongside the actual warhead. In the lower atmosphere, air resistance would quickly strip away the lightweight balloons and leave the heavy warhead isolated. This simulation shows a vacuum. Without air resistance, a balloon and a 500-kilogram thermonuclear core fall at the exact same rate. When radar sweeps over these objects, it cannot detect any difference in mass or velocity. The central vulnerability of an exoatmospheric shield lies in the risk of destroying a balloon while the real weapon slips through. To solve the decoy problem, defense systems wait for the terminal phase. They use the atmosphere as a brutal filter to decelerate lightweight fakes. The surviving heavy warhead then drops into the upper atmosphere, entering the engagement envelope of terminal phase interceptors like THAAD for a final kill attempt. Understanding the orbital math and kinetic physics defining this window is exactly what you can master with Brilliant. Brilliant's interactive lessons let you directly manipulate the variables behind gravitational pull and atmospheric drag equations, showing you how these physical laws govern orbital trajectories in real time. The laws of physics dictate both the unstoppable nature of the threat and the microscopic mathematical window we have to intercept it. This leads to the geopolitical reality of missile defense economics. The Iron Dome functions because it trades a $50,000 interceptor for an $80 rocket. Countering a peer adversary's global ICBM arsenal with kinetic kill vehicles that cost hundreds of millions of dollars each is mathematically unsustainable. Because no layered shield is economically or physically flawless, global security continues to rely on the promise of mutually assured destruction. To understand the origins of this nightmare, we have to look back at the Cold War and the American Nike Zeus program. Click the video on your screen to see declassified footage of an era when the military's only proposed solution to stop an incoming nuclear weapon was to detonate